What's going on, guys? Let's look at this problem right here. Here this question is asking a 300 horsepower, 440 voltage, 560 ampere, 863 revolutions per minute shunt DC motor has been tested and the following data were taken. Blocked rotor test. VA is equal to 16.3 voltage exclusive of brushes. IA is equal to 500 ampere. VF is equal to 440 voltage. IF is equal to 8.86 ampere. No load operation. VA is equal to 16.3 voltage including brushes. IF is equal to 8.76 ampere. IA is equal to 23.1 ampere. N is equal to 863 revolutions per minute. What is the motor's efficiency at the rated conditions? Note, assume that the brush voltage drop is 2 voltage. Second, the core loss is to be determined at an armature voltage equal to the armature voltage under full load. Third, stray load losses are 1% of full load. Okay, and that's it. Now let's go ahead and calculate the armature resistance, RA. That is equivalent to VA BR over IA BR. VA BR is 16.3 voltage. IA BR is 500 ampere. And that is equivalent to 0.0326 ohm. Now let's write some note right here. Under no load conditions, the core and mechanical losses taken together that is the rotational losses. Of this motor. Are equal to the product of the internal generated voltage EA, of the internal generated voltage EA and the armature current IA and the armature current IA. Since this is no output power from the motor, at no load conditions therefore the rotational losses at rated speed can be found as EA is equal to VA minus V brush VA minus V brush minus IARA. VA is equal to 442 voltage minus V brush is 2 voltage minus IA is 23.1 ampere. 23.1 ampere times RA is 0.0326. That's what we calculated right here. 0.0326 326 ohm. If you calculate this one, you're going to get 439.2 voltage, and P rot is equal to P con. That can be calculated using this formula, EA times IA. EA is 439.2. That's what we calculated right here, and IA is 23.1. 23.1, and that gives us 10.15 kilowatts. Now the input power to the motor at full load is P in input power to the motor at full load, VT times IL. VT times IL. VT is given 440 times IL. IL is given right here, 560 ampere, and if you calculate, you're going to get 246.4 kilowatts. And now the next thing is we are going to calculate the output power from the motor at full load. P out is equal to P in minus P copper minus P rot minus P brush minus P stray. Now here we don't know the PCU, we have to calculate the PCU. To calculate the PCU, this is the formula. PCU is equal to IA square times RA plus VF IA square. IA is 500, so 500 ampere square, and then 0.0326 ohm plus 440 voltage times 8.86 ampere, and that's equivalent to 12.05 kilowatts. Now the next thing is we are going to find out the brush's losses. That is P brush. P brush is equal to V brush times IA. V brush is 2 voltage times IA is 500 ampere. That is equal to 1000 watts. Now let's get rid of these things. Now P out is equal to P in minus PCU minus P rot minus P brush minus P stray. P out is equal to 24.6 250. Let's put it 246.4 kilowatts minus 12.05 kilowatts minus 10.15 kilowatts minus 1 kilowatts minus 2.46 kilowatts, and that gives us 220.74 kilowatts. Now the next thing is we are going to calculate the motor's efficiency at full load. That is neta is equal to P out divided by P in times 100%. That's equivalent to P out is P out. We calculated that one previously. That is 220.74 kilowatts divided by P in, that is 246.4 kilowatts multiplied by 100%, and that gives us 89.59%, and that is the neta value. And that's how we do this kind of problems. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn electromechanical system, there are a bunch of videos in my playlist. I hope you guys watch that too. Don't forget to subscribe. See you next time.